Hello, and welcome to today's live stream, Understanding Our Winter Watershed. My name is Amanda Major, and I'm the Outreach and Events Coordinator at Connecticut River Conservancy. Today, we're getting curious as we journey below our winter river surface to take a deeper look at what our watershed is up to this time of year. We'll hear more about the shifts in the river's ecology throughout the colder winter months with a focused look at the seasonal structure of a river, along with a snapshot of the flora and fauna. Then we'll head up north to explore decades of snowpack research based in the headwaters on the Sleepers River in Vermont. And finally, we'll tie in some information about our CRC's Water Quality Monitor program's Winter Focus and how you can get involved. What a journey we have in store today. I want to share a few reminders before we get started. Please keep your mic on mute during the presentation so our speakers can be heard without distractions. We love and encourage your questions. Please type them into the chat in the lower portion of your screen. We'll save time at the end to answer as many as possible. And as always, feel free to depart whenever it's best for you. We're recording this episode and we'll post it on our YouTube channel. And you can also view recordings of past live streams there. And finally, I'll be sending out an email later today with a link to the recording, some follow-up resources, and other ways you can stay connected to CRC's current work. All right. So, our speakers. Our first speaker will be Matt Devine. Matt is a fisheries biologist with the Connecticut Department of Energy and Environmental Protection. His work in the cold water program centers around habitat restoration, enhancing wild trout populations, developing public access, and community outreach. Matt is also a PhD candidate in the Department of Environmental Conservation at UMass Amherst, where his research focuses on the population dynamics and restoration ecology of river herring. Our second speaker is Jamie Shanley. Jamie has been working as a research hydrologist and biogeochemist at the U.S. Geological Survey. From 1985 to 1991, Jamie researched acid rain at both the Atlanta and Boston USGS offices. Presently, Jamie is the principal investigator at Sleepers River Research Watershed in Danville, Vermont, a long-term outdoor laboratory for forest hydrology and biogeochemistry. Jamie has been conducting research in the headwaters of the Connecticut River for 3 decades, including extensive work on winter melt events and their implications for water quality. He has facilitated other short-term projects in Puerto Rico, Alaska, and Germany. Jamie has a bachelor's in environmental engineering, a master's in environmental science, and a PhD in geology and geophysics from the University of Wyoming. Our final speaker is Melissa Langley. Melissa is CRC's Lab and Monitoring Coordinator, where she coordinates all the lab work and volunteer monitors for seasonal water quality monitoring programs, where we assess bacteria, nutrients, and cyanobacteria. Melissa has a range of experience in water quality lab work, salt marsh restoration, grant writing, and permitting. She holds a master's in environmental conservation from UMass Amherst, where she studied the successes and shortcomings of tidal restoration projects in salt marshes on Cape Cod. We're so thrilled about this wonderful speaker lineup today. Now let's get into our winter watershed adventure. Take it away, Matt.
All right, thanks, Amanda. Let's share. All right, hopefully we're seeing my slide. All right, can everyone hear me okay? All right, well, good afternoon, everyone. Thanks for spending part of your day with us. I'm really glad to see so many people interested in rivers and here, especially during a season when most of us, myself included, aren't really thinking about rivers quite as much. You know, when we picture rivers, we usually imagine spring runoff or paddling or looking at the fall colors along the river, and winter tends to feel, you know, more like this quiet season, like things have slowed down or even stopped. But one of the most interesting things about river systems in winter is that they're actually one of the most important times of year. And that's something I hope to impart on you today. So today we're going to go beneath the surface, take a look at what's happening with some of these critters in the Connecticut River, some of the ecological and physical processes, and things that we don't normally see, and talk about, how this season shapes the rest of the year in these watersheds. So we're really going to start rethinking what winter really means for a river. Before we dive in, Amanda had a nice introduction, and I'll just briefly expand on what I do day to day and how it relates. But as a fisheries biologist, a lot of my work focuses on trout and salmon, everything from stocking programs to managing wild trout and improving equitable access to people along the river corridors. And, a big part of my job is understanding how rivers function across the entire year. And one thing that becomes, quickly apparent in my work is that, what happens in winter often explains what happens the rest of the year and months later regarding some of these aquatic organisms. So a lot of the ecological decisions and what we see in fish populations are happening and being decided right now in the winter. And I'll just say, I have the best job in the world. My office is the rivers and streams, lakes and ponds, and my uniform is a pair of waders. So it's hard to beat that. So I'm very grateful, and I come to work every day very excited. All right, so let's dive in. Winter is an active season. It's something I would hope to, a take-home message for all of us today, because when we think about rivers, this is what I think about oftentimes. It's we're paddling, we're fishing, we're swimming, and winter feels like this off season, but it's not a dormant period. And in contrast, it's actually a structuring season. It's a shaping season of what months and years to come will look like. So energy is being conserved, habitats are being selected for, water's being stored across the landscape, and some of these biological outcomes for fish and wildlife are being decided right now. So, rather than thinking of winter as a pause, it's kind of more accurate to think of it as a preparation stage and getting ready to reorganize the rest of the year. And winter looks different all along the Connecticut River. It's a chain of different winter habitats that are all connected together, right? So there's one river, but there's many different winters, and the conditions can change depending on where you are along that corridor. So the Connecticut River spans more than 400 miles, and winter doesn't look the same everywhere. So take the headwaters, for example. Some of these smaller, colder streams with less volume of input, they typically freeze more consistently. They're up in the uplands or the mountains. And as you experience some of these larger tributaries, they might respond more quickly to weather events, to changes in flow and temperature. And then when you look at the main stem, whether it's the lower river or the tidal river, you have large volume of water, right? There's more stable temperatures and oftentimes more open water. Although this year has been quite different. We've had a heck of a year. And so the connectivity between those reaches is critical for survival and ecological processes for the rest of the year, and something I think a lot about in my work. All right, so let's dive under the ice. We'll start with fish. What are fish doing? Well, they're not snoozing, right? They're not actually sleeping, and fish don't hibernate. Sure, their metabolism slows down. They start conserving energy, and they seek refuge in places like deep, slow-moving pools with, lower velocity. Sometimes they hunker down where there's strong groundwater inputs and influence. A lot of fish, especially in lakes and ponds, I know we're talking about rivers, but in the rivers too, they'll just hunker down and bury half themselves in the mud, in the sediment. So they're slowing down their systems big time, and it's an energy limited season, right? So they're living off stored reserves, and they're feeding very little, depending on the species. And so if the habitat is poor, the conditions fluctuate, there's a potential for survival and recruitment in that next season to suffer. Summer is a pretty stressful period with increased and elevated water temperatures and potentially dissolved oxygen limitations. But winter decides who's even going to make it to spring and summer. So it's a critical time when those small differences in refuge suitability and habitat suitability can have large outcomes. Elsewhere in the food web, bugs, aquatic insects, most of them spend their winter as larvae, hunkering down under rocks and the sediments. And again, they slow down. Growth doesn't stop. It's continuous but slower. And then these insects are still super important and form the foundation of the winter food web. And they strongly influence fish condition and fitness come the spring. So some of the common critters that we might see are stoneflies and caddis, mayfly, and midge larvae. And so what's important here to note is that, any differences in the abundance or the density or the species composition of aquatic insects can have large impacts on fish condition and explain any variability we might see come spring and summer. We can trace that back to what's happening with aquatic insects in the winter. And of course, insects aren't alone down there. Many aquatic plants also persist right through the winter in rivers. We may not see them, or we may see what we perceive as kind of dead and dying leaves. And beneath the surface, the roots, the rhizomes, or the stems, they remain alive. And they're pretty active, and they're storing energy, and they're maintaining that structure, which is super important because, as you can imagine, those plants provide habitat and shelter for aquatic insects and small fish. They continue to help shape the dissolved oxygen climate under the water, and they help stabilize sediments and keep those roots in place, which helps stabilize sediments and banks and some of that physical characteristics of the river. So I like to think of it as not a system reset in the winter, but more like an ecosystem running on low power mode. Kind of like you're not going to put your computer to sleep or shut it down or turn it off, but it might just kind of go into a low power mode. And that's how I think of what's happening for the biodiversity underneath the water in the winter. Kind of coming back to the surface and on the terrestrial landscape, rivers in winter become especially important for wildlife because they act as travel corridors. And we know that connectivity is super important in the life cycles of a lot of species of critters that we study and follow and like to watch. And so if snow covers the landscape and frozen wetlands, it might limit movement in a lot of places, but the river banks often remain accessible. And so these areas where ice meets the open water can become biological hotspots. And they can concentrate food, they can attract a wide range of wildlife and animals. And some of our usual suspects are otters, and people may have seen minks, and of course bald eagles have made an incredible recovery on the river, lots of species of waterfowl. And so they take advantage of these predictable conditions and feeding opportunities. And predictability is something we'll come back to in a second. But this last bullet I had here that says compressed habitat, refuge becomes even more critical. And what I mean by that, one way to think about this is that in summer, animals can use many parts of the riverscape, from the land to the open water, the margins, the backwaters, the eddies. But in winter, the suitable habitat available really shrinks. And so winter becomes this potential bottleneck, to survival. And so any refuge habitat that's suitable really becomes that much more important to these animals. So even though it may look quiet to us, the rivers are actually, very alive, and there are the spaces that are open are very useful and critical to the wildlife. So they become these lifelines. So, and winter doesn't just affect these organisms, right? It changes how the river itself, the morphology, the function, the physical aspects of the river behaves. So, for example, ice reorganizes conditions, right? It can limit light penetration. It alters how the water moves through the channel and the flow. you can imagine how it might be destructive with large shelf ice or ice chunks reshaping the physical banks and the bottom contours. Um, snowpack acts like a temporary water storage. And so instead of immediately running off and running downriver, water's held up in the upper watershed in the landscape until spring melt, which is really important for humans and wildlife. Cold temperatures do slow down a lot of the processes that happen year round. So, decomposition happens slower. Nutrients might cycle more gradually and slower, and then the plant growth is reduced. But remember, not stopped, just reduced. And so again, these ecosystems shift into this kind of low energy state rather than completely shutting down. I mentioned the floods. You may see, let's see if I have another picture. Yeah. This chocolate milk color of the rivers we see when a lot of sediment and spring runoff is moving wood and debris. And it's fascinating to see, but that's the river at work setting the stage for spring. And the timing and the magnitude of this water movement and these floods during winter shapes what's next. So up until this point, I've talked a lot about how winter traditionally works in the river systems, but one of the biggest changes we're seeing is that winters are becoming less predictable, and this is important, right? Temperatures are warming overall, but just as important is the uncertainty around the timing and the magnitude of those changes. So we might be seeing more midwinter thaws and rain events falling on snow instead of snow falling on snow. Snowpack should and typically does act as a natural water storage, but when that becomes less consistent, that changes how the water moves through the system. And what this looks like locally at our watershed is that we see more winter flooding in some years. We might see shorter periods of stable ice cover, and then an earlier spring runoff. And so some of these events and changes can alter the phenology or the timing of seasonal events for fish and wildlife, plants and animals who have evolved and adapted with this predictability. So, rivers have evolved with these predictable winters, and variability is kind of changing the rules. It's rewriting the game. And so why should we care about variability? Well, like I mentioned, and just to expand that these ecosystems and the rivers that we know and love, they've adapted to not just cold temperatures, but to these predictable seasonal patterns. Historically, winter conditions might have changed gradually. Ice formed, flow stabilized, and organisms adjusted their behavior accordingly. And when winters become more variable, like we're seeing, for example, with repeated freeze thaw cycles or sudden rain events, that disturbance over and over and over again has these cumulative effects on species and their success, their overall population dynamics. So, so I would argue that stability, more than temperature alone, is what many river organisms depend on. So even if you have a slightly warmer but unstable winter, that can be more stressful than a consistently cold one. It's not so much the cold temperatures that limit these critters, it's the variability and fluctuations that they're not used to. And so to kind of illustrate this point, this is a hydrograph from the USGS stream gauge. I forget exactly where, somewhere north of Holyoke, showing on the left y-axis it's discharge or cubic feet per second, and on the right y-axis it's temperature in degrees Celsius. So that thicker line you're seeing is the flow, and that thinner line is temperature. And this is throughout the whole year. And I'll draw your attention over to the right side, which is winter there. And you'll see instead of steady conditions, there's sharp spikes that are occurring. And these spikes are basically winter storms that move through the system quickly. Those vertical bars that are purplish, those represent times when ice interrupted the stream gauge. And so, there's ice forming, coming and going. But historically, winter flows were more stable. And now increasingly, we're seeing hydrographs like this that have rapid rather than gradual changes. And then looking at temperature, instead of remaining steadily cold, having stable temperatures, the temperatures bounce around like you see in these circles. And it may not look like much, but it reinforces this unpredictability. And again, these slight changes can trigger life history traits of species that might get them moving to the next season, but really it's kind of like a false signal. So again, this unpredictability is one of the bigger challenges. Let's bring it back to like a human dimensions aspect. Why do rivers matter to us? Up until now, we've talked about the ecosystem, but it does shape our experience, right? The fishing, the paddling, the conditions we love and enjoy are set up now in the winter. Water quality is also shaped long before we notice it. What enters the winter river system now, whether it's salts or nutrients, that moves through the system and affects conditions later on. Same with flood risk. So, but it's important to me, and I think important to many of us, if not all of us on this call, is what rivers do to us socially, physically, mentally. Beyond the science, winter offers something else, and that's, I think, a perspective. And so when you spend time along the rivers, we start to notice patterns, and those are worth taking notes about. Those are worth enjoying because those changes, those matter. And again, just being along the river or having the river near you in your peripheral is, for me, it does wonders. It makes me a more happy person. I want to leave you with just some actionable items that come to mind for me. And it's, you don't have to save the world individually, right? That's not what we're after. I think all of us can take small individual actions that can lead to bigger things, community actions as well, and then just observing and being stewards. So, without getting into too many details, we can reduce road salts. We can protect stream side vegetation. This one might have the highest ecological payoff. Leave natural vegetation along the banks. Keep the riparian buffers intact, and support those local ordinances that do so. Kind of on a municipal level, and to get more engaged, you could support land conservation efforts, join wetlands commissions and be an advocate in that way. And then something I like to do, I get my kids out, be curious, notice and document, participate in citizen science. And, CRC has amazing volunteer and water quality, chloride monitoring opportunities. So all those things, volunteering, just help build that connection and stewardship to the river. And I'll just leave you with this. This is a picture I took actually yesterday. I went snowboarding. I climbed to the top of Mount Tom where that old ski mountain was and snowboarded down and had a blast. It was really good for me. And you can see the Connecticut River just poking through the trees back there, all frozen over. And I think it's important to remember that we're connected to the river even when we're not on it. You don't have to be paddling, fishing, swimming. You can be, but you don't have to be. You can be along its banks reading a book. You can be at the top of a mountain just looking down on it, gazing. But the river connects us. It has connected us all through time. And I think that's something that we could and need and should keep with us, that connectivity with us, knowing that the river is always a part of us. So thanks for your time. I know I'm right up against it, and I will stop sharing and turn it over to Jamie.
Great. Thank you, Matt. Everybody hear me okay? And see me? And oh yeah, great job, Matt. I clapped
Thanks.
too. That was awesome. Matt introduced some of the things I'll talk about, and I'm going to echo a lot of his comments about winter not being dormant. He talked, mainly about the biology not being dormant, and I'll talk about some of that too, and certainly hydrologically, it's it's not as dormant as it used to be, with, as Matt pointed out, more of these sort of midwinter flow events. But let me get into my presentation here. Wrong slide. So, okay, you seeing my first slide full screen?
Not quite yet.
Really? Maybe I didn't share properly. Says I'm screen sharing, but there. Now do you see it?
Yes.
Okay, great. Okay, now it's full screen for you. Okay, so great, awesome. So I titled my talk "The Perspectives from the Vermont Headwaters." So Matt talked a little bit about headwater streams and how things change going downstream. We do most of our research up in northeastern Vermont, in the Sleepers River Watershed, in this very small headwater catchment. The watershed area is about 100 acres. I told my kids growing up that was going after the 100-acre woods. And we are really we've been really winter oriented in this watershed. It's funny, within the USGS, people talk about, oh, what are you going to do in the summer field season? Well, our field season was always more in the winter. We spent an average of 3 days a week out in the watershed in the winter, and only more like 1.5 in the summer. So we're really focused on the winter, measuring snow and snowmelt runoff. And that's really been a lot of our focus. So appropriate that I could maybe bring some winter perspective to the day today. And I also wanted to say, even though this is a very small stream, so this is the stream gauge at the mouth of that 100-acre watershed. And even above that weir, we do have a remnant brook trout population. So that's really cool. And I'm never really been clear whether that it is a remnant population or if fish actually can make it over this weir. But I will talk about sort of the effect of our stream gauge weirs on fish passage in a little bit. I also wanted to mention that this is an awesome place to work and to see wildlife. Matt mentioned mink and otters. We have the animal I love seeing out here is another member of the weasel family, the fisher, and I've been able to see those like 3 or 4 times. That's a spectacular mammal. So we are up in the headwaters. The Sleepers River is within the Passumpsic River watershed, that red hatched area there. So we're pretty far north. And the weir I just showed you, the stream gauge, is at 1,700 feet. So we're pretty high up, and we do get a reliable snowpack every winter. So here's a map of the watershed. Do you see my cursor moving around here?
Yes.
Hopefully. Great. So the whole watershed is 42 square miles, and it's very near the town of St. Johnsbury. You might be familiar with. It's about an hour north of the Hanover, White River Junction area, right up I-91. So we're to the west of St. Johnsbury, and the western boundary of the watershed is the Kittredge Hills, and these come up to about 2,500 feet, whereas the outlet to the whole watershed is only about 600 feet. So there's a lot of relief in the watershed. But as I mentioned, and the photo I showed is the W9 watershed, where we do most of our research, the 100-acre area. And here's a blow up of that. So we have different gauges there, and we do lots of winter measurements around that watershed. And we say we have the best view of New Hampshire and all of Vermont, because we look out to the east and you can see the White Mountains here. This is the Franconia Ridge, Cannon Mountain ski area, Mount Moosilauke to the right. And you can't see it in this picture, but we have a great view of Mount Washington as well. That would have been off to the left. So the Sleepers River watershed started in 1958 by the Agricultural Research Service. Originally, there were 16 stream gauges and 25 weather stations. Now we're down to 4 stream gauges and about 7 weather stations, but keeping going what we can. That was set up to study hydrology in the northeastern glaciated environment. And we're looking a lot at snow and snowmelt processes and looking at hydrology, how water moves from the rain and snow melt into the streams. We study that whole process. And also, like the chemicals that move along with that water, you really have to understand how the water's moving and then study the chemistry. Do the chemicals or pollutants move with the water? Do they get hung up in the soil? So we study that whole gamut of processes. And originally, we were studying acid rain. At times we studied mercury movement because that's an atmospheric pollutant that comes in with the rain and snow. But now we're really focusing mostly on the whole carbon cycle and carbon moving out of this forested landscape and into the river. But talk about our snow work now. In the Northeast, we have these really layered snowpacks. So these show up because we applied dye to the surface of the snow, and as we had melt events, the dye kind of infiltrates and pulls up wherever we have a impeding layer, usually an ice layer or a crust layer. And so you can really see each and every layer, and there's about 10 of them in this snowpack that's only about 2 feet deep here. So it's a really graphic image of how layered our snowpack is. And out west, we tend not to see such layering. We have sort of more consistent cold winters, and this layering never develops to the same extent. So we've got a 65-year snow record now, and this is what it looks like. This is the maximum snow depth each annual maximum. And it's in centimeters, so I put where 5 feet would be. So in general, we have somewhere between 2.5 and 4.5 feet of maximum snowpack. And again, this is pretty high elevation, so you might not see this at your house, but over 2,000 feet in the northern Green Mountains, this is what we see, and it's pretty cool. But a striking feature of our snowpack trend is that there's not really any trend. If you look at these sure do see some high peaks there in the early 70s, but overall, there's not really a trend. And this really differs from a lot of other areas, and we're trying to decipher out why our snowpack is so much more reliable. But in general, we're just not getting as much snow in the Northeast as we used to. As Matt pointed out, this year is a bit of an exception. But all those measurements I just showed were done by hand, and this is our method of the snow tube. It's hanging from a scale right now because once we get a core of the snowpack, we weigh it to measure how much water is actually in the snowpack, because it's really the amount of water in the snowpack that really dictates, what the flooding is going to look like, more so than the depth. We could have a foot of snow, but there could be anywhere from 1 inch if it's really fluffy to 4 inches if it's really compact of water. So we really want to know how much water is in. That's why we weigh the snow core. And unfortunately, my colleague Serena is standing in front of the teeth on this snow coring tube because we actually have to rotate that tube into the snowpack to get the through those layers that I was showing earlier. And just wanted to briefly show some of the more higher tech methods we have of measuring snow. On the left is a snowpack analyzer. This is something that Syracuse University has put out at our watershed, and it measures the water content of the snow, that diagonal band labeled with the A there, that measures the snow water equivalent, or the water content in the snow. And that circle there, labeled B, is an acoustic sensor that measures the snow depth by the time it takes a sound wave to bounce off the snowpack and back up. And then more traditional method, the snow melt on the top right. This is we measured snow melt by the melt went into this drain, and we measured it in a building nearby. And this is how we sample for snow with these capillary samplers that suck up the snow melt water. So I want to show an annual hydrograph. Matt showed something very similar, and he was focusing on the winter period, which is sort of off to the left here. The green here is the snow melt period, and we see a lot of high peaks. And what I wanted to point out, though, is that we keep seeing these peaks, the green as sort of the end of snowmelt, which ends by the end of April. And we still keep seeing these big peaks after. And think about why that might be. Why, when the snow is gone, why do we still have these high peaks? Well, because the subsequent rain events are landing on a landscape like this. This is late April up in the watershed, and there's just so much saturated ground that any incoming precipitation keeps running off. And also the groundwater levels are really high. But that whole snowmelt period sets the stage for the summer. And the tail of this snowmelt hydrograph lasts well into the summer, all the way into September, really, before it finally starts to pick back up with fall rains. So it's really the amount of snow melt in the winter here that, in the spring, that dictates how much flow we're going to have through the summer. But the winter is shifting. This schematic shows kind of a historical winter where the snowpack kind of stays on the ground and the chemicals stored in the snowpack. And this is a student doing her project on nitrate right now. So I have one of her graphics there, Addie Hedges, showing the nitrate just gets stored in the snowpack. In the traditional historic winter where the pack just stays there. But now with these more winter events, rain on snow, we get a lot more of these subsurface pathways to bring the water and nitrate into the stream. We have higher stream flows in the winter, and that nitrate is going down to Long Island Sound where they don't want it. So when we make that case that studying the headwaters and the nitrate dynamics up there is really important. Of the 16 stream gauges, they were all these big concrete structures. And now, since we're not using most of them anymore, some of them are slated for removal. And we have the Nature Conservancy and other groups working to get rid of some of our stream gauging weirs, which gives me mixed emotions, but I support the fish passage. Since we're not using them, why not just get rid of them? Just some of the other ways we study hydrology. Here's one of our small stream gauges in winter. We measure soil water coming down through the soil and groundwater with a lot of wells around the watershed. And as I mentioned, one of our big focus is dissolved organic carbon and how that's moving down through the system. And if you look, the blue dots are what the dissolved organic carbon is at base flow. It's really at low levels. But the yellow dots are what happens during events. This big cluster is snowmelt. These are summer and fall rainstorms. And the concentrations really go up. And that can be a big hazard for downstream environments where they're pulling drinking water from the river, because this especially high humic DOC, which is what we get off the forested landscape, can really interfere with or interact with the chlorine that's used to treat drinking water and can cause carcinogenic disinfection byproducts. So we're working with treatment plant operators to kind of help warn them when these events are coming. So I think I'm probably going a little too slow here. I'm going to talk a little bit about some of our stream measurements. I don't have a lot of slides left, but I wanted to talk about our how we measure flow, the U.S. Geological Survey. And what we do is we take a channel and we divide it into these little sections and try to measure the flow in each one with a velocity meter to get the velocity, and then we know the area of each section, and we add these all up to get the total flow of the river. And this is a picture of someone doing that measurement. It's often done wading. Sometimes it's done with cableways over the river or from a bridge. But in the winter, that gets a lot more problematic. So here we see a person making the same measurement over the ice, and to get those little mini subsections, they have to drill a hole in the ice, lower their velocity meter into the hole, and get that velocity measurement. So it's a lot trickier in the winter, especially in conditions like this. That is actually one of our stream gauging huts, where we measure the water level every 15 minutes. But when you have this kind of condition, you might get a water level, but it might not mean very much because you have the ice damming up the water, and all kinds of problems. So Matt showed a hydrograph with some gaps in it, and those gaps are because of these ice conditions where you can't really rely on the water level that your gauge is telling you, and you have to sort of reconstruct it after the fact. Just another shot, and this one, and I'm sorry, but these shots are actually from the state of Maine. They had some great photos they sent me over. And this is actually the capital of Maine, Augusta, with snow melt and ice-affected river creeping up on the edge of the city. So I think I'm back on schedule, and this is actually my last slide. I just wanted to talk about the changes to rivers in the winter, and what's going on in a changing climate. So my watershed does appear to be an exception, but overall we're having a lower snowpack, and we're getting smaller snow melts as a result, and they tend to be earlier. And we're getting more of these rain events during the winter, rain falling on the snowpack. So this potentially will lead to lower stream flow in the summer, and compounded on that, as we've heard recently, we have a lot more drought in the summer period. So if you have lower flow going in and then you have a drought, that can lead to really low flow conditions in the summer. So that's sort of the general rule. We're tending toward lower flows in the summer. But as to whether this translates into lower flooding in the spring snowmelt period, that's kind of a mixed bag, because these rain events can be really large. And as I pointed out, the rain's falling on saturated ground. So we can still get really high flows in the spring. And then I don't have this in here, but we've also had really big floods in the summer recently. Even though the ground is really dry, the runoff can be really high in the summer, and the intensity of rain appears to be increasing. So we're having a lot more flooding in the summer as well. So that's about what I had today. And I guess we're going to have a joint question session for both of our presentations now after Melissa presents. And that reminds me that Melissa's going to be talking about chloride. And I did want to mention that, we're measuring all the major solutes in water. We do measure chloride, and even up here in the headwaters, not so much in that 100-acre watershed, but in some of our larger watersheds within the Sleepers River Research Watershed, we are seeing pretty high chloride levels. So I'm going to hand it off to Melissa now to talk more about chloride. Thank you.
Hi, everyone. Can you hear me? I think I should be good.
Yeah. Yes.
Thanks for joining. I'm Melissa Langley, and I'm the Lab and Monitoring Coordinator at CRC, and Amanda has been kind enough to share my slides with you. I'm going to talk briefly about chloride, road salt, and what you can do to help. So chloride is the main ingredient in most road salts. Sometimes other kinds of salts are used, but that's primarily the one that we have. And it's used to lower the temperature at which water freezes. And this increases the safety of roads and walkways, but unfortunately, it also has negative impacts on our waterways and the organisms that live in the rivers. And these freshwater plants and animals that, we're maybe familiar with near us, and particularly those with permeable skin like frogs, they're not used to these increased chloride levels. So chronic and acute exposure can hurt them and even kill them. And so CRC works with the Isaac Walton League and volunteers to sample chloride in the watershed. This is a program we started in 2024, was our first year of monitoring for chloride. And the Isaac Walton League also offers suggestions for proper road salt techniques to reduce the effects on our rivers. And so we can go to the next slide. Um, Thank you. So what can you do to help? You can help by monitoring with us at a river spot that you care about. And Amanda will include some resources on how to get involved. And anyone across the watershed can do this. So there's no need to live close to the Greenfield lab or have any prior experience in water quality monitoring. This is sort of unique in our programs because most of our monitoring is limited by how close the sampling spot is to the lab, just because most of our sampling involves lab work. And so this is a really exciting way to get involved, even if you live kind of in a more far-flung region of the watershed. And you can also learn about safer salting practices like using brine and sweeping up excess salt to help keep extra chloride out of our waterways. And then lastly, you can get involved in legislation in local, state, or federal levels to regulate, help us to regulate the use of road salt and advocate for safer practices. If you live in Vermont, there was, I think, the legislative session either just happened or is about to happen to pass a salt bill, and there's similar legislation at different regulatory levels. And yeah, that's all I have for today. I've included my contact information below, and I'll hand it back over to Amanda, who does so much work to organize and run these live streams. So thank you, Amanda.
Thank you so much, Melissa. And thanks, Jamie and Matt, for all the awesome info that you just shared with us. Let's slide into the Q&A session. Does anyone have any questions? You're welcome to put them in the chat, or we can just unmute and you can speak your truth. I saw in the chat there was a question about this link asks for a login. Yes, the platform that we use for our volunteer management, it requires you to create a login so that we have some information about you and you can sign a waiver through that. So thanks for that question, Stephen. Ron says Vermont legislature is in session now, FYI. Any questions about your winter watershed? Arlene asks, what's in the Vermont bill? And we'll go to Stephen and Stuart after that.
Sorry.
Yep.
Yeah, so I don't know a huge number of the details, but my understanding, our river steward for Vermont is out this week. She's in Italy. So she would have more information on this question, and I'm happy to ask her. But I think that it's primarily regulating the use of salt. And there are a lot of different people who, are licensed to use different salting techniques. So there are commercial applicators, and then, we have state applicators. And those, I think the regulations can be kind of different. The oversight is different. And so my understanding is that's primarily what's in the bill.
Thanks, Melissa. I'm going to slide over to Stephen. Stephen, do you want to unmute and ask your question?
Sure, yeah. Thank you for all this really great information. I live in Hartford, Connecticut, and grew up more closer to the area that you're researching there, Jamie. So sort of like top to bottom of the watershed, I feel connected to. And one thing that is very noticeable this winter, especially, is how variable the ice cover can be. We've had like pretty steady, like near solid river here down in Hartford for the past, month almost, it seems. And I wonder if someone could just share more about the impact that like varying ice on the river has, either ecologically or geologically.
Yeah, this seems more like a question for Matt, but I'll just weigh in a little bit on the hydrology, and that is that um, it is more difficult to get that measurement under the ice in the winter, and the flow record can be compromised a little bit, even though the USGS people do work their magic to reconstruct the flows. But if Matt wants to talk about any biological effects.
Yeah, sure. Good question, Stephen. I think what comes to mind for me is just having open water in some places versus others. I think it, open water was going to provide those biological hotspots more frequently, and depending on where that happens in the watershed, might open up more river corridors and connectivity than might happen otherwise. So, yeah, I think if you have less ice, variable ice, it's probably benefiting some species and of plants and animals. Good question.
Awesome. Thanks, Stephen. We're going to head to Stuart and then Patricia. You had a question, and then I'll scoot back to the chat for folks who are typing in their questions. So, Stuart, let's hear what you are curious about.
Thank you. Thanks, Amanda. I think a few people are touching on this, and you just mentioned it yourself, Matt. I'm interested about specifically your species monitoring in the winter and how this informs some of the projects or the planning that CRC decides to do in other parts of the year. I just a bit more understanding about how you're looking at some monitoring parts of your work. And I guess to Jamie, the question I was interested in is how you are sharing your information across the watershed. You mentioned the importance of hydrological flows and carbon and other issues. And I'm just wondering how you're working with and speaking to other agencies and organizations downstream, and how well that information is taken on board. Thank you.
Yeah, great questions. I'll quickly touch on what I think Stuart's asking on my end is how does the winter and the conditions affect and impact our sampling and our monitoring? And it's challenging. Open water is what we prefer. We can't run nets through. Well, I guess I shouldn't say that. Anything's possible, and we have drilled holes and put nets underneath. But it makes monitoring hard. That's why the bulk of our bread and butter sampling season is spring to fall, and then we stop short in fall because that's when a lot of our species are depositing eggs, going through their spawning cycles. So it makes it challenging. It limits where and what we can do, but we use other techniques. So we might tag fish and use radio telemetry to monitor their movement up and down the river, which is a relatively passive monitoring technique that allows us to get valuable information on movement and timing. So we kind of play that game, if you will, and go under the ice to the extent that we can. But our typical like nets, electrofishing, angling surveys are less frequent. So we'll use tagging, and then we do ice fishing on a year like this year is very popular. So we'll go out and intercept face to face as many anglers as possible and ask them questions about their fishing and desires and opinions. So,
yeah. And just a quick answer to the question about how we're sharing information and working with other agencies. So a lot of our information is in scientific publications, which is not that user-friendly to the public itself, but we are keep making an effort to be more public-facing and are working that way. I'm going to be sharing a link, or Amanda will be sending out a link to our website, which I have to apologize is painfully out of date. We're in the process of updating it, but it'll at least be a start. But a lot of our information is online. Of course, all the USGS streamflow information is online, probably over 100 sites throughout New England, including many on the Connecticut River. And as far as the dissolved organic carbon, there are some sites in the lower Connecticut that are monitoring that continuously, and those are publicly available. I'll share links to that with Amanda as well. And just to finalize that, we had to convince the people in Connecticut and Massachusetts that are doing like CT Deep and the Mass DEP that the headwaters are important, and you really need to, they're worried about nitrate pollution, and you have to worry about what's happening in the headwaters. So we made that case, and it's gotten some traction. So we are doing some projects to sort of track the nitrate downstream. And I just wanted, one last thing is echo Matt's comment about the winter not being dormant. A lot of that nitrate is produced under the snowpack, so that's happening during the winter by microbes.
Great.
Yeah.
All right, Patricia, did you want to ask your question, and then we'll slide to the chat? You are on mute right now, so yeah.
Okay, I live in Essex on a cove. The cove is very near the Connecticut River and is tidal from the river. It's a 50-unit condo complex, and so we have a landscaper who does also winter plowing. They apply quite a bit of salt, and so I'm wondering, this is 50 units. Would there be regulations that Connecticut DEP or some other branch has with respect to salt use and
disposal?
Jamie, I'll chime in quickly to the
Yeah, go
extent
ahead.
of what I know. It's a good question, Patricia. So I think the short answer is, from my perspective, and I can dig into more, I don't think we have a ton of legal teeth when it comes to that. We have standard operating procedures. We have guidelines that we suggest to the Department of Transportation, and we do some of our own monitoring. But when like the rubber meets the road, I don't actually know the process. I'd have to dive in more to our water quality and water bureau. But most of the times we put forth guidelines, recommendations, research, and then it's often out of our hands, unfortunately. But
Yeah,
I'm sure there's more to the story. That's just a limited amount I know.
Where would you suggest that I would look to see if there are even guidelines that I could put in the hands of these landscapers? And
yeah, I mean, outside of this, I can email you what I know. You can probably search our website and very quickly find our habitat and conservation and enhancement group that they'll probably have links to salt application, PFAS testing, wood in rivers, things like that. They'll have a document for each issue, if you will.
Good. If you could email me that, I'd like to make it available to the board of the condo association.
Sure.
Okay, that would be great.
Yeah, I'm happy to facilitate that connection too. If
good.
you want to reach out, Patricia, but I can also send those resources to the whole group so that people can kind of dig in themselves.
Oh, okay. And you've got our emails, so you could send them.
Yes, I will send a follow-up email after this with the recording and some additional resources that we've been kind of mentioning throughout the.
One quick thing that's interesting and a little disheartening, all this snow that we've had, it's great if you like winter. There was just a press release yesterday that CT Deep is permitting municipalities and towns and cities to deposit of plowed snow in waterways. So that's not common, and you can imagine that's not ideal based on what we're talking about. So, I feel like that's just hitting home the point that we could have all the guidelines we want, and then at the end of the day, push comes to shove, it's like we need somewhere to put this snow. We're going to dump it in the waterways, and I would hope that we're moving beyond dumping in the waterways. But that's a real world example of how we're pushing snow in the water and permitting it because we can't put it anywhere else.
Yeah.
All right. Thanks for that question, Patricia. I appreciate it. There's a few resources that popped up in the chat. In response to the questions about the Vermont bill, there's a link that you can check out. And Tracy also put New Hampshire had 2 road salt bills this year, one on its use and storage and another adding a fee to support salt management in the program and provide grants, but both bills have been killed by the House of Reps. So if you'd like to follow up, there's some resources there. There's also great guidelines by Salt Watch, so I can add that to our follow-up email. And then Kate Buckman, our aquatic ecologist at CRC, said both Connecticut and New Hampshire have Green Snow Pro trainings that focus on best practices. Alrighty, let's see. A few more questions up here. Emily is curious about what the process is for helping with the water quality monitoring. Melissa, can you let us know?
Yeah, so if you're interested in specifically the chloride monitoring, I think that the link to our volunteer platform, VOMO, is in the chat and will be linked, I believe, somewhere when Amanda sends out the resources. And so you can create a free account on VOMO and sign up that way. And basically you'd get a kit in the mail with 4 chloride test strips. And you can monitor really wherever you like. If there's a river spot that you're interested in, we do recommend that people monitor at a tributary rather than on the main stem of the Connecticut, only because it's often quite dilute by the time it reaches the main stem, but there are no rules about that. You know, you can, if that's what you prefer, then that's totally fine. And then, so most of our monitoring, as I mentioned, takes place in the warmer seasons. And so we're kind of gearing up for that. And we have volunteer sort of e-blasts and recruitment emails that go out when we're ready for that. And so we have E. coli and other monitoring throughout the watershed. And so you can keep an eye out for those or sign up for the volunteer emails so that you'll get those notifications. And you're also always welcome to email me directly, and I'm happy to chat about what program or volunteer opportunity you might be specifically interested in, and especially like based on, you know, depending on where you're based.
Thank you. I do want to know it's 1:03 right now, and we promised that we'd wrap by 1, but we do have quite a few more questions that I'd love to get to. So our speakers agreed to stay on a little bit longer. If you have to leave, we'll send the recording this afternoon. So fear not, you will not miss it. So the next question is from Mike. Is anyone measuring PFAS in snowmelt?
I'll speak to that. It's ironic. We actually submitted a proposal to do just that last winter, and it got really high reviews, but no funding. Funding is very competitive these days. So we were really disappointed by that, but we've kept up our efforts to find another venue for submitting that proposal and getting some funding. But it's a great question. Like, to what? So you're probably thinking about places where we know we have a PFAS problem. Like downstream in the Connecticut River. Our proposal really wanted to get at, is PFAS even, you know, it's the forever chemical and it's maybe the everywhere chemical. So our question was, do we see it in the montane headwaters? So that's really what we wanted to look at. And there's some evidence that even up in our north woods, we will be seeing it. And also wanted to measure it in precipitation, because that's really how it spreads. So there are some programs that are starting to look at it, at least in the bigger rivers, but I can't really put my hands. I'll try to come up with some resources on that and include them with the stuff I'll send to Amanda later today.
Yeah,
but
I can do.
Just one other aspect. So they are starting. There's a nationwide program that looks at precipitation chemistry. It started in the acid rain era, and they are adding a PFAS element to that. So that those data are starting to become available. I can put a link to that as well.
Cool.
Thanks, Jamie. Matt?
I can look into if that's the case. I know for us it mostly focuses on drinking water, one-off events like spills and whatnot, and then discharge and sewage water. So we also actually test fish tissue lately for some of these contaminants. So I think we're broadening, recognizing how widespread the issue is.
Great, thanks, Phil. The next question we have, can Matt talk a little bit about what might be happening with brook trout eggs under fluctuating temperature or flow headwater conditions in a changing winter, if we know?
Man, that's a great question. It's complex, but I think we do know some things. I think what's alarming is when you have maybe warmer winters, what that's going to do is maybe preemptively or prematurely lead to embryo development, maybe hatching, and what you end up with is like an offset. I don't know if that's the right word, but a mismatch of when these fish are hatched, what food is available to them at that time. So, I think a lot about mismatching in the timing and the phenology of things. In terms of flow, I think drought is one of the biggest issues, especially when there's not good groundwater inputs. So you can imagine how if, let's say, a fish is hatched early due to warm temperatures, it might be hatched into a period of low flows or high flows where it can't find the margins of a small stream and it gets washed downstream, and the redds and the nests and the eggs get scoured, and it becomes this really bad feedback cycle. So I think overall there's a lot of negative impacts, and an indirect impact that we're seeing a lot, and this is the super strong signal, is that brook trout are becoming displaced from areas where they really should be, like these upland streams and these small tributaries and these seeps, with brown trout, this more warm water tolerant species that can outcompete brook trout. They have a same spawning season, so they can compete for eggs. And that's alarming because brook trout are retreating and retreating and retreating. And, you have this brown trout, which is not native to the area and endemic, and they are displacing brook trout in large numbers in places where they shouldn't be. And that's a direct result of warming water temperatures. So yeah, it's not a good thing. That's a good question. And there's a lot more to it. But we're still learning. It's a work in progress for sure. Good question.
All right, and we have one last question. They're saying it's off topic, but there are a number of wild skating enthusiasts in the Upper Valley. Shouldn't they be concerned about water level fluctuations under the ice? Maybe not give any recommendations, just in case.
I think it's always good to be conservative when you're on the ice, even if it's 14 inches thick, because it can change from 1 foot to the next. I go on the ice a lot. We stock trout through the ice, and so I'm routinely monitoring the conditions. And this year is as good as it's going to get, but there's still people falling through the ice. There's still patches of groundwater seeps that make one place unstable versus another. There's kind of tributary streams that carve their way through areas. So yeah, I think being concerned is having a healthy amount of concern is good.
Great. Well, that looks like it's the end of our questions. Just a lot of gratitude to all of our speakers today. So thank you all for the excellent information you've shared. And thanks to all the attendees for joining today to learn more about our watershed and what's going on in the winter. And we hope to see you next month on Wednesday, March 18th at 12 p.m., same time, same place, for a live stream on fish passage design. We have more information, and the registration link is live on our website at ctriver.org/events. Thanks again, everyone, and have a lovely day, and good luck this winter.
Yes. Thanks, everybody.
Great. Yeah. Thank you, everybody.